Okay, welcome everyone to this week's office hours. My name is Ahmed Kira. I'm part of the Cribl Solutions Engineering team, and today I'm going to talk to you about some better practices for using AWS S3 with Cribl LogStrean. So let's go ahead and get started. I have quite a packed agenda today, and I wouldn't be surprised if I go up to the full hour. First, just a quick look at why we're here, that a lot of you today, a lot of customers are adopting S3 as a new data lake. And in doing so, it's okay. It's pretty easy to doing it at a few gigabytes per day or something like that. But there are some scaling considerations that we have to take into account if we're going to do terabytes per day. So we're going to talk through some of those. And then I got 10, that's right, I have 10 things here, 10 better practices, as I'm labeling them, for you all to consider as you are adopting S3 as your new data lake with Cribl. And one of those top 10 is really around what we call partition expressions. So if time permitting, I have some exercises for us to look at some partition expression examples and decide what's good, what's not good. And worst case, if I don't go through all of them, it's in the slide deck and you'll be able to see this afterwards. So why are we here? Again, everybody is starting to look more at object storage as a data lake, and S3, Amazon S3 is really become the gold standard for that. A lot of other vendors have also adopted S3 APIs so that you can write to their platforms via the S3 protocol. It's economical. You're not bound to any disk size like you would if it was a block storage on your systems. Amazon says it's durable with 11 nines, right? That's pretty astounding. And then it's agnostic and reusable. So various reasons there that people have adopted S3, Amazon S3 in particular, as their standard for a data lake. And as you already know, Cribl both can read from S3 and we can write to S3 as a destination. And so we're on board with customers being able to fulfill that strategy of using S3 as a data lake. But when we do this, how do we do this behind the scenes? There's really a few things here that you got to keep in mind, because we don't just read the data, process it, and then send it directly to an S3 bucket. We actually do something else with it that we call staging. So we actually will queue up the data in this staging directory, and we'll queue it up until either it ages out. So we'll say, keep the data for up to 5 minutes, keep growing the files for up to 5 minutes, or until the file gets up to a certain size, right? We'll keep doing that in these staging directories. And based on what we will see later, that's called a partition expression, we will create subdirectories in the staging directory for that. And then within each one of these staging directories, the subdirectories really, you're going to have different files. And these files will remain open. These files will remain open on the system until we ship the data out to S3. And okay, one file open isn't a big deal, but if you think about your typical partition expressions where you have things like host, source type, and maybe some other fields, you can easily have tens of thousands, if not even in an edge situation, hundreds of thousands of open files. Hopefully you'll never get to that point. But open files is a big deal, as we'll see here in the rest of this presentation. So open files, we optionally will compress the files as well. So that's an option you have to select from in the UI within Cribl, and then we finally push it to S3. All right, what are the main considerations here that we have to consider or keep in mind? I've broken this out into 3 categories: AWS, Cribl, LogStream as an application, and on the Linux OS itself. So at the S3 level, this is something that I mistook, by the way, here until recently, but you have API limits for both writing and reading. But what I originally thought was for what a prefix was just like a top level directory, it's not. a prefix is actually the entire directory that you're writing the objects to. So if it's 10 slashes in that directory, that whole thing is an entire prefix. That means for that whole directory, you have 3,500 writes per second and 5,500 reads per second that you're allowed. So that's actually very helpful, right? It almost negates the S3 APIs as issues or as a potential issue, but we still have to be aware of it. And if you ever exceed that rate, you will get a CloudTrail message on that S3 bucket that tells you the rate has been exceeded. So we'll talk to you about how you can monitor that here in a little bit. But here's straight out of the AWS documentation that backs up what we just said, that a prefix is the complete path in front of the object name, right? It's not just a top-level directory, it's the complete path. And then with Cribl, as an application, what are the main things that we have to be aware of or keep in mind? One, remember that we stage the data. We keep it in these staging directories. So we need to have available disk. We need to have available open files on the operating system in order to accommodate all of these different files that we create and keep queuing basically until we send it off to S3. And what we just talked about prefix with AWS, LogStrean has this concept of a key prefix in the destination and a partition expression. Do not confuse an AWS S3 prefix with what we call a key prefix in LogStrean. They are not the same thing. In fact, what a S3 prefix is really this key prefix plus the partition expression. Let me just quickly show that to you here in the Cribl UI. So here's one of the destinations to an S3, and a key prefix plus the partition expression together, they would be the equivalent of an AWS prefix. Okay, just keep that in mind. Do not confuse key prefix for an AWS S3 prefix. All right, let's get into some better practices. And remember, there's 10 of these, so hopefully I can finish them all in time. The first one, kind of taking us to London here in the underground, and it's not about minding the gap, it's about minding your partition expressions. And what is a partition expression if you haven't seen that before? In the UI for Cribl, when you go to one of the S3 destinations, you'll notice it is one of the fields here. And this is where we basically tell Cribl what directory we want to put in place when we write to S3. And you want to be careful with this partition expression. You don't want to have what's called cardinality to be too high. The cardinality has to be reasonable, if you will. Otherwise, you'll have way too many open files, and you might have as well some other queuing issues as a result of that. So partition expression. And also, there's another piece here that a lot of us also forget about, and that is this file name prefix. So notice there's partition expression is right above here, but file name prefix is another one if we scroll down in the UI, where we can create a partition or basically a different names for our files, not just the directories where they reside. And this is both good and bad, because if we have too many of these, if we create too many of these files, guess what? That's going to then accumulate the number of files in one directory. And when you need to do a replay now, later on, one of the security analysts needs to do a replay. And let's say there are over 6,000, over 5,500 files in the one directory, you might exceed your API limits. So you have to be careful with these two settings, the partition expression and the prefix, file name prefix expressions together. And we talked about cardinality. You don't want to have a crazy high cardinality. What's the importance of cardinality, and why can it become a problem very quickly? To demonstrate that, we've got here a diagram similar to how the virus propagates, right? So one person here, if the one person has it and is in contact with two people, then that person is in contact with 2 other people and so on. You're going to easily distribute this thing very quickly. So similarly with partition expressions, if you have one directory or one parameter as your partition expression, so say host as that top level one, okay, maybe it's actually number 1 here is no partition expression. So pardon me, number 1 is no partition expression. You're going to put everything in one directory. And then that one directory, now you're going to have a lot of files, right? That's could be an issue when you read because you're putting so many files in one place, potentially as well when you write, because now you have to write potentially a lot of files into one directory. But then you do the host. So let's do host for number 2 here, the one variable, but there's only 2 values for host. Okay, so you're going to have 2 directories where everything goes. All right, that's not a problem, but only 2 values. How many? Are you really going to only have 2 values for host? Usually it's going to be hundreds or thousands. So think about that. And then if you do 2 variables then, so let's now say source type. Similarly, now you're going to have, instead of 2 directories, now you're going to have 4. And if we just keep on going down the chain here, if we have 7 variables, all with 2 values, you have 128 directories that are going to be managed by Cribl in the staging directory, and accordingly, as many open files with that. And what's the magic number really of the number of partition expression cardinality that you should consider? We'll get to that here in a second, but if you have a cardinality that's too high, what problems might you have? And it's going to be the too many open files. That's going to be the main thing that you have to consider. Too many open files. Can your system handle 100,000, 200,000 open files? Probably not, right? So you have to keep things like that in mind. Versus if your cardinality is too low, then you have a larger chance of hitting your API limits with S3, AWS S3 in particular, especially when you're reading, right? Writing might not be so much of an issue, but reading for sure could be an issue. And that magic number for what is the cardinality, maximum cardinality you should consider for any partition expression, the number to take away here is 2,000. Now, this number is subject to change. You can have it higher, but this is kind of the baseline, if you will, just a number to target. And within the UI, within the Cribl UI, back to the destination here, and you go to advanced settings, there is a max open file setting over here. Default is 100. So we're not going to let you raise that beyond 2,000. 2,000 is the highest that you're allowed to keep that at as of today in the product. So think of 2,000 as the maximum values you can have for any cardinality. And so now you're thinking to yourself, okay, how the heck am I going to determine the cardinality for my partition expression? So 1, you need to identify the fields that you want to put in. And 2, then you can either do some math, or as what we're doing here, we're actually running a search on our analytics platform and finding out basically how many unique values might we have over any period of time. In my case here, the period of time is 3 minutes. So I have 2 searches here. You can take a wild guess what platform this is. In this platform, I am basically going off of a source field. I'm going off of a host field, and I'm going off of a source type field. So I have 3 fields here to consider for my partition expression. And by going 3 minutes, I'm going to use a timeout of 3 minutes within Cribl. And that's why I'm using 3 minutes here. If I'm going to use a timeout of 5 minutes, then I'd want to raise this to 5M instead of 3M. And then down here now in the chart, the resulting chart, we can see that most of the time here, kind of the 90th percentile, if you will, is about 1,600, 1,624. But we do have these spikes of 2,500 that occur from time to time. That's okay. Having spikes over 2,000 is okay, as long as they don't happen too frequently. Why is that? Anytime we go over 2,000, so let's say we set 2,000 as our max open files in Cribl, and we also set up our operating system to allow a lot of open files. Once we hit 2,000 open files by any one worker process, Okay, that's the key here. In any one worker process, we're going to close all of those files at the same time. All right, we're going to close all of those files at the same time, ship them all to AWS at the same time. And then any new data that comes in, now you're going to have new open files that keep accumulating. All right, so important thing to distinguish there is the closing of all files at the same time if we ever reach our maximum partition expression on a per worker process level. And if it happens once every few minutes, once every minute, maybe even, probably not a big deal. But if it keeps happening every few seconds, you got a bigger issue definitely to resolve at that point. And if you don't have the data already somewhere to be able to search on it, how else can you determine what your cardinality is for the partition expression that you desire? Here's an example where now you just basically look at what are the various fields that you need. So here we have source type, host, and attack type. And then we consider how many possible maximums do we have for each one of these, right? And then from there, we multiply all these together to come up with the highest possible cardinality. Now, consider though, are you within your timeout period? So in my previous example is 3 minutes. Am I going to ever have 2,500 values, or am I going to have fewer? Right. So that's something else you'd want to consider is that time range aspect of it. What is that cardinality over your designated timeout period? So the first one's good because we're close to the 2,000. And then the next one, though, is where, you can maybe get a little carried away, where say we want to put source IP address as our partition expression. Well, you can have 65,000 potential values there, right? Are you going to have 65,000 in any one moment in time or in 3 minutes? Probably not, but you can still have a pretty large cardinality. You can bet it's going to be well over 2,000. So using something like source IP on an internet-facing address is probably not a good idea for your partition expression. But you can still have IP addresses in a partition expression where, let's say, for example, you're looking at web server logs and you only have so many web servers, maybe 20, maybe 100, let's say. And because you have a finite number like that, that's why putting something like the destination IP of that server basically it becomes okay, because now you can still be around or below the 2,000 magic number. So a couple of ways there to figure out what your cardinality is of your partition expression, either searching your current analytic tool or doing math like we have here. And at the very end of this, I have a few other examples, but in there I actually have a lot more considerations to keep in mind. And if we have time, we'll get into those and maybe have other people here on the line chime in and give your opinion as far as whether it's good or bad. All right, number 2 out of 10. Keep your users happy. And what are we talking about here? Why do you create partition expressions? What's the purpose of creating a partition expression? It's to help your people when they need to do replays, when they need to fetch this data in the future or analyze it again, potentially with some other tool. They need to be able to filter on it easily. So that's where we say, create the partition expression on commonly searched fields, and obviously within reason. So here's an example where we've got 2 different S3 destinations configured in Cribl. They actually are going to the exact same bucket. Okay, they're going to a bucket called archive, but you can see we have a key prefix. This is the Cribl prefix, not the AWS S3 prefix. A key prefix of pan-threat here, a key prefix of app access log. So that's going to be the top level directory. So we can easily filter on those. But then inside here, we're going off of host and attack type because those are the 2 main fields that people search on for the pan-threat data. And then for the Apache access logs, well, here we've got the server IP, the status code, and the method. as the fields that we're specifying there. And how did we come up with those? We asked the users, what fields do you care to search on the most? And then we took the main fields, all those fields that they told us, and then we tried to come up with a cardinality across all those fields, right? And then we added them up across all the different destinations that we have. Each one of them, not all of them, but each one of them shouldn't be more than 2,000. So this one here shouldn't be more than 2,000. This one here should not be more than 2,000 because again, on a per destination level in LogStream, you're not allowed to have more than 2,000 on a per destination level. Number 3, this one can be an afterthought for a lot of us, but put your replay, allocate it or dedicate it to its own worker group. Do not put it on the same worker group that you're streaming real-time data coming in. While you could, do you really want to risk adding so many resources from having to do this replay and bringing up terabytes of data potentially alongside all of your incoming production data? Probably not, right? We don't really usually think about that until we factor something like that into account. So have your replays on a dedicated worker group. Do not use the same worker groups that you're sending real-time data through. And on that note, this is a perfect use case where you can use Kubernetes and have it auto-scale the workers while your people are doing the replays, right? Or AWS Spot instances are a heck of a lot cheaper than regular instances. You can use those as well and just keep it running for as long as people are doing the replays. So dedicated worker group for replays, pretty important. The next one, and another number here to just have kind of as a one to have as a leave behind. And it's about sizing your disk for the staging location and how much data is going to be written to that staging location. Mind you, I am only factoring here S3 staging. I'm not factoring in here persistent queuing that might be enabled for other destinations, right? This is strictly for staging, S3 destination staging. And the number to keep in mind or just have as a leave behind is for every 1 terabyte that you have of incoming data on any one worker, you need 100 gigabytes of disk. So think to yourself, if you have, here we got 3 examples. If you have 10 terabytes per day, and you have 7 workers doing that work, 100 gigabyte disk each, or 100 gigabytes per those 10 terabytes, excuse me, across the 7 hosts, that's 143 gigabytes that you'll need at least there on that for staging for that one S3 destination. And what are I come up with this number? I came up with this considering that you might have up to 2 hours worth of data in the staging directory. In reality, are you ever going to have 2 hours worth of data in the staging directory? Hopefully not, because your timeouts are usually going to be 1 minute, 5 minutes, maybe 10 minutes, let's say. So you're really never going to have more than 10 minutes worth of data in the staging directory. So by going very conservative and using 2 hours, you're leaving yourself a lot of extra room in case something does happen and you do have, or you do need that much space, right? That's 10x, right? 10x what you might need, maybe 20x what you might need for a typical timeouts, maximum timeouts that you'll have for your S3 destinations. All right, so just consider that number. Just have a number to remember. So what's the other number we have to remember? The 2,000. 2,000 cardinality for partition expressions, and then the 100 gigabytes for every 1 terabyte per day per worker. Number 5. We talked about 2,000 as the maximum cardinality for an S3 destination. Remember that cardinality though, and the configuration of it in Cribl is per worker process. So if we have a cardinality of 2,000, any one worker process might have 2,000 files open at any one moment in time. So if you have a 32 CPU system, so that means you have 30 workers, 30 worker processes, that is. 30 times 2,000 open files each, that's 60,000 open files potentially on the system, right? So you need to have now the system updated to accommodate that many open files. And this is where you can basically run these various commands, update these various files, and keep track of and validate the settings there that you have enough open files on the system. And my understanding as well, with newer versions, kernel versions of Linux, you can actually go higher than the 65,000 that you previously might have been limited to. It's now, I've seen some systems that have 100,000 as their max open files. Number 6, and this one that we can spend a lot of time on because there's so many settings, but tune your LogStream destination settings. In particular, the max open files we talked about that cannot be greater than 2,000. But should you keep it always at the maximum? Probably not a good idea unless you have your operating system all set up, you have enough disk space, and you really did your work with cardinality and so on. So max open files, keep that, or this will be 2,000 max. But then your max open file time, right now here it's 60 seconds. Match, when you're trying to figure out your cardinality, match the timestamp that you're searching in your analytic tool against what you plan on having here. So if you are, first you start, let's say, with 5 minutes. You're looking at what's your cardinality over 5 minutes, and you come up with a number that is 5,000. Well, that's too much. So maybe you'll bring it down to a minute, run your search again in your analytics platform, have a span of 1 minute to see what is the maximum number of unique values you have every 1 minute. And now your number goes down to 2,200, let's say. Well, that's much better, right? So you can bring it down to 60 seconds as your max open file timeout, knowing that you're pretty close or that you're within the range there of the max open files. And then a couple of other ones here that we'll actually get into a little bit. To lower your costs with AWS, we're going to talk a little bit about intelligent tiering as an option. But if you aren't expecting too many replays, then infrequent access makes sense, because then it'll be cheaper to write it there. And you're only going to be billed extra then after that when you query the data. So if you query the data too many times, if you're expecting a lot of replays, this is probably not a good idea. But that's where intelligent tiering comes into play, where it will automatically take the older data that is not searched or that has not been fetched at all before. It's going to put it into a lower tier that's going to be cheaper for you in the long run. And a few other settings here as well. One other one that should be called out is the format, the data format that you write to S3. So by default, it's JSON. So what does that mean? When all of the events that Cribl will basically send to S3 as JSON, you're going to have the raw event as one field, and then you're going to have a bunch of Cribl fields and other fields as metadata that are going to be shipped into these events basically as a JSON payload. Versus raw, where we just take the original syslog event or the original event that came, say, from CloudTrail and send that on to the S3 bucket as is. Compression is also usually something you want to enable, right, to dramatically lower your costs, because you got compression anywhere from 70 to 90% typically for most of the data sets here. So yeah, the raw format and compression, two main other fields there to update. And on the topic of lowering AWS costs, one thing that we don't really think about too much is if we're putting our workers in AWS, we are charged when we export data out of our VPC and send it to S3. Even though it's going to another AWS service, they're charging you. Unless you have something called an S3 VPC endpoint or a different VPC endpoint that enables you to basically negate those charges. So in this top level example here, you have an internet gateway that would be required for sending data out to an S3 bucket. You're going to accumulate charges here. You have a private subnet here with no route to the internet. Well, guess what? You're not going to be able to send anything to S3. But down here, this is where now you have a private subnet. You have an S3 VPC endpoint. It could be a public subnet as well. And now, because you have this S3 VPC endpoint, it'll basically negate the charges, the outgoing charges to your S3 bucket. And it might not seem like a lot, but it adds up over a year. And then to reference that S3 VPC endpoint, you have to, within the LogStream UI, for the destination, you're going to come to advanced settings. And right here is where you'll populate that endpoint. And that's how you can benefit from that substantial cost reduction. And then the other one here that can help, and preface here on can help with AWS costs because it'll heavily depend on how you use your data, is writing to what's called intelligent tiered storage. I went to AWS's pricing page here, calculator page. So this is where you just go to AWS Amazon S3 pricing. There is a section where you can select, I want to estimate my price for S3 for these different tiers. And so I went in, selected standard and infrequent access, and I also selected intelligent tiering. And with intelligent tiering, the less you search your data, it'll get rolled off to other tiers, if you will. It'll go to infrequent access tier if you're not basically accessing that data for 30 days. And if you don't access it for 90 days, it'll go to a different tier and so on. So it's basically automatically managing that data for you and where it goes. And as a result of doing that, it helps you reduce your cost if you don't touch the data at all. And here's an example where I took the same exact numbers. So I'm assuming here 60 terabytes per month that we're writing to an S3 bucket. So that'll be 2 terabytes or so a day. And to populate all those 60 terabytes, 30 million put requests. So 30 million files, let's say. But then we're searching and we return 5 million of those from people doing replays throughout the month. So putting those numbers in to the standard tier, the infrequent access tier, and then similar for intelligent here are the costs that I get between those three. And you can see standard tier is the most expensive at $1,500. The intelligent tier is slightly more than the infrequent access tier here at $1,100. So use it, put your own numbers in as far as your how much do you think is going to be searched versus not searched, and to come up with your own numbers here more accurately. And also just another thing to call out here, this is also taken directly from the AWS documentation. S3 intelligent tiering, standard and bulk date retrieval and restore costs are free of charge. Free of charge across all 5 access tiers. So something definitely worth taking a look at to control your AWS costs. Monitoring. We can't have observability tool here if we don't talk about monitoring. And so how can you make sure you don't go over your limits with API limits with AWS S3? There's a CloudTrail event for that. And earlier we said that it's the rate exceeded message. So that's wherever you put your CloudTrail logs in your SIEM in an analytics platform, or just in AWS with the new service that they have, the CloudTrail Data Lake, as it's called. What events do you want to look for? You want to look for a rate exceeded, but this is also, here's a search up here that shows you all the various messages you have for your S3 buckets. And I'm looking at event name, error code, error message, and the ARN of the S3 bucket. And notice here, we've got a lot of access denieds a life cycle policy that didn't, complete. But again, the one you care about the most here to make sure Cribl is actually writing the way it should is this rate exceeded message, which luckily we don't have any listed here, but the access denieds could be an issue if Cribl is writing to those buckets. But it doesn't stop at just logs. There are also some metrics that you can use to track if you're ever going over your API limits. And to enable those, they're kind of in a hidden place. You have to go into your S3 bucket where you're writing data. You gotta then go to the metrics tab over here. And within the metrics tab, you're gonna go to view additional charts. And then just following these numbers here, request metrics, you're gonna create a filter. The scope of the filter is gonna be a prefix. So if you have a large partition expression, how the heck are you supposed to create one of these for every prefix? You're not. This is where you want to probably take the prefixes where you're having the most writes, let's say, and put those over here as the filters, right? Put those as the filters, the prefix filters. And then once you do that, you'll be able to track all of your API requests, reads and writes, put requests, and then there's also other charts that will show. And then up in the top left here, or top right, sorry, there's a view in Cloudwatch, which now allows you to use Cloudwatch or any other observability tool to basically track those metrics. But until you do this, you're not going to see these options at all or any of these metrics in Cloudwatch. You can't just go to Cloudwatch right now before doing this and find these metrics. You're not going to find them. You have to enable them here first. More metrics, but now at the operating system level where you have your worker nodes running. So just keep these in mind. You can monitor these with Cloudwatch if you have this in AWS. You can also use Cribl AppScope to track these metrics. And then another useful command here that you can run on your operating system to just see how many open files, because remember, why do we care about partition expressions? One of the main things is too many open files. You can track your open files with a command like this over here. All right, finally here, number 10. Enable notifications for your S3 destinations. So Cribl LogStream has this notification capability where you can basically, anytime there's an unhealthy destination or a back pressure is activated here, and there's another scenario, you can get a notification. So if you're ever having trouble with your S3 destination, you can enable the notification within LogStream. And one other thing to call out here, there's this option, remove staging directories. In fact, let's just go here to quickly take a look at that. Under advanced settings, remove staging directories. You will want to have this enabled so that Cribl, as it's creating all these directories from your partition expressions, will delete them soon after it's done with them. However, only do this with version 3.2.2 or later. 3.2.2 is coming out in the next few days here. This is January 12th right now, 2022. So enable this in 3.2.2 because we've identified an issue where right now, until 3.2.2, best to have it disabled, and use this as a cron job. Set up a cron job as the Cribl user, the user that Cribl's running and have the files instead deleted via this cron job. We're incorporating this type of logic in the product. So in 3.2.2 is when it'll be safe to enable remove staging directories. And with that, what are the main takeaways here? 2 numbers to remember. 2,000 is the max cardinality, and 100 gigabytes for every 1 terabyte that you're doing on any one worker, right? So 2,000 and 100. And then recap of everything. Brain overload, I'm sure, for most of us. These are the 10 better practices that we've covered here, but they are important to consider in order to be able to write to S3 continuously and reliably, as well as be able to accommodate your replays or anticipated replays from S3 as your data lake. So with that, there hasn't been any questions or comments throughout. Let's just stop here and see what kind of questions we might have. And did I miss anything in the chat? Is there anything there?
Nothing there. Yeah, that was a lot to run through. It's 42 minutes. That's impressive. So we are recording. We will have this up on YouTube. It'll be a great reference as well. Questions, comments, anyone out there? If we don't have questions around this specifically, we've got a lot of folks on here that can answer questions and other questions as well. I think we got something from, let's see, something we put in the chat here.
So Mark, yes, we'll go through a couple of examples here in just a few minutes. Great suggestion. And Michael is asking, what are the commonly seen mistakes? The commonly seen mistakes is people will ignore this advanced settings tab and what's everything that's in here. People will not do their homework with the cardinality, determining the cardinality, and not come in here and set max file open timeout, right? So takeaway there is do your homework with your cardinality and adjust this setting to match a cardinality that you have close to 2000, right? That's one key mistake there that people generally overlook. And then maybe another one is having one destination, right? Having one S3 destination, just saying source type and host and putting everything via that one destination. Break it out. Create a different destination for how people are going to filter for different data sets, like we were talking about earlier. Make your users happy. Those are probably the two main mistakes that people overlook or don't think to do when it comes to writing to S3. So definitely keep those in mind. Any other questions, comments before we go into these examples that Mark is also wanting to see?
I think I'm good. I'm just getting started, so.
Okay. All right, well, let's go through these exercises here. And here's the first one. Is this a good or a bad partition expression and why? And then we'll first just open it up to people on the phone here on the Zoom session to give their opinion. And then we'll see whether it's fine or not fine. So what are we doing here? We're basically telling it just populate the year, the month, the day, and the hour as the directory structure in the S3 bucket, and then put all the files underneath there. So is this a good or a bad partition expression? Should I pick on anybody?
I would say it's good if you have less than 2,000 per hour.
2,000 per hour, okay. All right, so what's the likelihood that we'll have less than 2,000
None.
per hour, okay. All right, so here are the questions to basically ask, and Claudio is spot on there. Potential cardinality every hour. One, because we're putting the cardinality here. There's one directory. All the files are going to one directory. So really, what this is all the files are going to go into one directory. And how many open files if we have 30 worker processes? So we have one partition here. Every process is going to open up a different file and basically just keep appending to it until the timeout is reached. So we're going to have one file for every worker process. So it's 30 open files that we're going to have. Not many, but let's keep going here with these questions. So how many files then in the S3 prefix now if the timeout is a default of 60 seconds? So we didn't, do our homework. We just did 60 seconds here as a default timeout. What's the maximum number of files in the S3 prefix? And this one, we're 30 files every minute, basically, right? And then they all get closed 60 seconds later. And so 60 minutes in an hour, that's 1,800 files that we'd have in that S3 prefix. And so what if there are 10 nodes now in our worker group that are doing this as well? So we don't just have one worker group doing this, we have 10. So now we have 18,000 files that can be in that one S3 bucket prefix. And while we've written all those 18,000, spread out over an hour, we don't have an issue for writing. But because they're in one bucket, now if we want to do a replay, we need to fetch that data, we'll easily get over our API limit of 5,500. Right? So not a good partition expression. Next one here. Now, okay, we've added minute to the partition expression. So now we're going down to the minute for every directory or every prefix that we create in S3. So is this a good one or a bad one? Let's see, is it, here we go. So cardinality again, every minute now, not every hour, right? So we ask ourselves, what is the cardinality, maximum cardinality of the file over any particular period of time? And because the files will have a different directory basically every minute, we can go down to the per minute level here. You're still a cardinality of 1. So are we going to have the same API limits when we read? Well, let's keep going down here. So 30 worker processes, so 30 max open files at any moment in time. And the S3 prefix, now because we have down to the per minute, not to the hour, now we're creating a new directory every minute. And so every 60 seconds, we're going to have a maximum of 30 files that are created there, sent to the S3 prefix. And across 10 nodes doing this now, you're going to have 300 files instead of the 18,000 we had previously. So we're going to be well under the 5,500 there. So this can be acceptable, but why might this one be bad? The file sizes. Now you're going to be, instead of fetching, files that are a few kilobytes or megabytes, they're going to probably potentially be very large files, not much larger. So while this will work, this will be fine. When you do replays, opening the files and processing the files will take a little bit longer. All right, now for something that is more real world, because we don't usually just stop at the day or the hour. We look at fields that we have, like index, host, or source type. Right? So let's take a look at this partition expression. And here are some assumptions we have to make. So we've done our homework. This is the part that people forget to do, the homework. We have a cardinality of 3,000 every 3 minutes off of these 3 fields. We have a file write timeout of 3 minutes that we're going to set up LogStrean with. We're going to assume that over those 3 minutes, the max file size is never reached. So let's say we have 100 megabytes as the max file size, but let's assume it's never reached. And then we have 10 workers in our group that are doing this. So similarly, you ask yourself various questions here to try to figure out whether this is a good or a bad partition. The first red flag is this is over 2,000. right? This 3000 is greater than a 2000. So that's an immediate red flag. And how many active subdirectories in the staging directory? Notice I say active here, is 3000, but really 2000 of them. But once you hit 2000 partition expression or cardinality, once you hit 2000 cardinality, some of those directories are going to be reset, if you will, right? And all the files that are in there are going to be sent over to S3. So you can probably argue that this number really should be 2000, right? You can make that argument. Excess cardinality, 1000. But what does this mean? What does it mean that you're greater than 2000 here? It's again, when one process goes up to 2000 cardinality, all the files get closed. And then new files start to accumulate from there, right? So we're potentially writing 2000 requests at one moment in time to AWS when that happens. If it happens too many times, then it might be an issue. But one every minute, few minutes, what have you, is okay. And if we have 14 worker processes now on a worker doing this, that's 14 times 2,000 open files maximum at any one moment in time, 28,000 open files that we have there. So we got to make sure to accommodate this. Our operating system has adequate open file settings, right? Because the default probably aren't going to work. And then why is this now a yellow or maybe okay, but keep your eye on it, is the potential for back pressure. So the part that we don't have here that we would be good to have is how many times, how frequently do we go over or go to this 3000, right? Can we lower our timeout to 2 minutes or 90 seconds and have a below 2000 cardinality? Right? That's the one question that we would want to ask ourselves to better this particular situation here. And then my last example, well, actually, in each one of these, I'm actually also going to solution to the prior situation. So here we need to track our max open files. And if it happens too frequently, so that if we are truly going at 3000 very frequently, then we need to reconsider and go down to the 2 minutes or 1 minute, just like we just said. And then last example, this one's a little bit more involved now because we're not just considering partition expression, but a file name prefix expression. Dun, dun, dun. And so now my general guidance is to stay away from file name prefix expressions unless you know what you're doing, unless you did your homework with cardinality and everything else and truly understand what the impact that will be on what that'll be for your API limits and such, right? So my suggestion is stay away from file name prefix unless you truly know what you're doing. Just focus on partition expression and leave file name expression as a default. But in this scenario, since we only got a few more minutes here, here's where this one might be an issue. And it was mainly introduced because of this file name prefix expression. By having this expression in here and only going up to the day up here, even though we have index, host, and source type we're still only up to the day. We can have up to 200,000 files in any one prefix. And guess what? When you want to do a replay, it'll be an issue. You're not going to see any issue writing to S3 with this, but it's when you do the replays that you'll start having issues. Hopefully that was educational. But here's also the solution to that prior slide. Again, stay away from file prefixes unless you really know what you're doing. And consider expanding the partition expression instead of using a file prefix instead, right? And then the reducing of the timeout can potentially help as well to lower the cardinality. And that is it. What do you guys think of these exercises? Did that help, Mark?
Can I do it again?
Yeah. Luckily, you'll have this slide deck. You'll have this recording. So you can pause it at any time and go through and maybe add some extra color on your own of why maybe something I might have forgotten to account for in these scenarios. But it's a good exercise at least to focus on what's important, and that's the cardinality.
Well,
2000
let's put it
cardinality.
that way, Ahmed. Before the session, I thought, that's so easy to write it on AWS S3 with Cribl. Now I'm a little bit, let's say more careful.
More careful, yes. Just doing your homework in advance, absolutely, to know so that you'll enjoy it for years to come. You'll enjoy it for years to come.
Ahmed, I want to thank you for this presentation. This is something I've seen some struggles with overall, because it's not just setting what your partitioning expression is. It's a lot more than that. And you covered the factors that are AWS and AWS limits, as well as Linux operating system and disk considerations. And it's not a simple case of just set your naming prefix and assume it's going to work. You need to account for things like IO bandwidth, write limits, or put limits and get limits. And the way that you articulated this is extremely helpful. So thank you for this.
You're very welcome, David. My pleasure.
That was great, Ahmed. Thank you. So we'll get this recording up on YouTube. And certainly if there's other questions, send them our way. We're back in 2 weeks on the 26th with Alex Kane. He's going to cover Linux packs, the Linux pack. So that'll be our next session. If anyone has ideas for things they'd like to see in the future, feel free to let me know or put it on the community Slack for the office hours channel. But everybody else have a good rest of your day. Appreciate the time.
Thanks, everyone.